Hello, let us continue. Where are we? So, last video we've already find out our integrating factor, which is 1 over x squared. And the next step is to multiply this integrating factor into our given differential equation so that we can now have an exact equation. So let me copy our given yan. So maybe let's use this already. Let's use this equation 2 in this which is already in this form. Okay, so let me copy this. Yan. So once again, we need to multiply our integrating factor in this equation 2. So our integrating factor is 1 over x squared, and by doing that, we now have a x squared all over x squared is just equal to 1 plus y squared all over x squared plus multiply by 1. So we have 1 over x squared dx. And then for this part, x divide x squared, so we have now a 1 over x plus 1 over x multiplied by x minus 2y dy is equal to 0. Okay, so from here, say this is our equation 3. Now our equation 3, it says here in our technique that if we multiply our integrating factor in our non-exact differential equation, it will become exact. So let's check if we've already already have an exact equation. So we have m, a partial derivative of m with respect to y is equal to, so this is our m, this is our m, and this is now our new n. Let's have an asterisk there. Okay, so we have derivative of constant is just 0, as well as this part here is 0 because x is we consider x as a constant. Since we consider x as constant, let me write it 1 over x squared, and then the derivative of y squared is just 2y. Okay, then for the partial derivative of n with respect to x, we will consider x as variable and y as constant. Okay, so now we have a maybe you can simplify this n further. We have x over x is 1 minus 2y all over x. Okay, so the derivative of 1 is just what you call this, 0, and then this term here is in form of division, so we need to do the derivative of the division. So we have low multiplied by the derivative of high is 0 minus high all over the derivative of denominator is x squared. So we have this, we have negative times negative 2y all over x squared. And by the way, if you also simplify this, we have 2y all over x squared. So this partial derivative of m here is already equal. So now we have just clearly see that our equation, differential equation. New differential equation after multiplying the integrating factor is now an exact equation. Okay, so this equation here is now an exact equation. Okay. So the next step, of course, is to perform the steps in what I call it, in computing the solution for this given differential equation. And if you do that, that yields to a general solution of y minus y squared all over x plus x minus 1 over x is equal to c. Okay, so this is now our general solution. And of course, I will leave it to you on how we have come up with this general solution. Okay, since we have already verified that we are now in the exact equation, you can now use the steps in exact equation to find the general solution. Okay, so that's all for this video, and see you next time. Thank you.